have three people on stage. Now, who are these three people? What are they going to do? And what are they discussing in front of us? It's actually a golden opportunity for you all to lend your ears to this exciting discussion. So what are they discussing? They're discussing about the factory of the future, embracing digital transformation with Industry 4.0. For this, we have Mr. Srikanth P J, Principal Generate Metamorph 3D Print Services, and Mr. Vimal Govind, founder of GenRobotics. And as our moderator, we have Roshan Kakkat, CEO, Media One TV. Can we have all of you all on stage, sir?
Ladies and gentlemen, today we have a wonderful topic called Future of Factory, Embracing Digital Transformation 4.0, right? In this region, traditionally there have been a lot of industries, manufacturing industries like steel, footwear, and tail factories. They have been operating in this region, and they are in the stage of digital transformation. To some extent, even they have introduced robotics and AI solution. So today this topic is going to be very relevant in terms of automation, digital transformation, and things like that. And I hope that there are a lot of delegates from those factories and their CTOs, their technology managers, and there are students, those who have been looking for the good placement and things like that. So we do have two wonderful speakers today. One, Mr. Srikanth. Srikanth basically is from Chennai and he's the general manager for Metamorph 3D prints. He's a corporate trainer and he's into business consulting. And he has been, coaching a lot of, entrepreneurs throughout the years. And he has acquired his, engineering degree in marketing plus digital automation plus, business process engineering in Leicester University in UK. And he's into many, industry organizations and also, technology platforms. So I welcome Mr. Srikanth to this session. And another wonderful speaker, Mr. Vimal. He is basically from Toronto. He is the man of robotics and AI solutions. He has also done his engineering from Calicut University and also done another, interesting factor. I was just going through his LinkedIn profile and I found, technology commercialization. That's very much interesting, and he has done this certification from UK. So let's hear from those two speakers, and I'll start with Mr. Srikanth. Srikanth, see, when we talk about this topic, to set the context, so what's your opening remarks in terms of, embracing digital transformation and, factory of the future?
Thank you very much, Vimal, and good evening, all. It's my pleasure to be here. First of all, I think life starts with gratitude. So my gratitude to Sailesh for making me my presence felt, the CEO of events. And as my friend as well, Matthew George from Siemens is also here. We all grew up in Godrej, CAD/CAM. So I'm sure many students are here. So when we started our journey, we were starting our journey in CAD/CAM in the 90s. And part of that came from my education in PhD Tech, where we had a subject on CAD/CAM. So what I'm saying is that I've come a full circle from CAD/CAM to printing, and I've been in printing and CAD peripherals for almost 2 decades, and back into printing. But now it's no longer printing, it's manufacturing. So the word 3D printing is actually become additive manufacturing. So you can see the world is changing and we need to embrace that change today. So the factory of the future is not far away. In fact, it is already happening. I'm not sure if it is happening in Kerala, but our prayers and wish is that in the next 5 years, as Dr. Santosh Babu said today, deep tech, we come under deep tech. So with deep tech, Kerala should become the hub, and Kozhikode, a very exciting, when looking from the hotel room, full greenery and environmentally friendly, love to be here. So it should also become a manufacturing hub. Now why and how can it become a manufacturing hub? What is the factory of the future? Do you think that we need large factories like steaming with so much of square feet of land, sheds, and you have to work in sweat and a lot of these things, and the nowadays engineers, they want everything in the touch of the button and gratitude at the touch of a button. Do you think we want that? No. Today, the factory of the future can be in an air-conditioned, smaller environment. In this room, you can have 20 or 30 plus machines or even 50 machines doing what a factory does. And all of you engineers who are out here can become entrepreneurs leading that factory with a very small investment. With that opening remarks, let me tell you what we have in store in factories of the future. So, as he said, advanced manufacturing technologies are today including 3D printing with disruptions of many things which are happening to manufacture, and are we ready for them? The market is already ready in terms of the technology availability, in terms of the industry readiness to some extent, but the gap is in the manpower, the skill, and the people to be able to bridge the gap between the technology and the industry, and that's what we are talking about today. So, I think already Matthew talked about this, so I'm not going to spend a lot of time. So, we have moved from 1.0 to 2.0 to 3.0 to 4.0 where we are today, where cyber physical systems, IoT, networking, machine learning is all happening. And then we moved to human robots. So, we have Vimal from robotics. And then mass customization, also to say customization, today you can have a car. Like he was talking about Henry Ford. Henry Ford said you can have a car as long as it is black. But today, you can have any car, any dashboard, any kind of alloy wheel, any kind of styling, any kind of bumper, customized fully. BMW has started doing it. Many other companies have I think Peugeot has started doing it. A lot of companies have started doing that. So you can have every part customized to what you need using additive manufacturing. Okay, so what is the history of an innovation? Little bit, you was talking about context setting. So quickly, so mechanical production from railroads, and then you have the second wave of mass production. Then we have the automated production of electronic components, computers. Then we have robotics and cloud computing, AI. And then you have human centricity and resilience and sustainability being talked a lot about. And now it is ubiquitous, virtualized, manufacturing, customer driven. So today, we are talking to industries today who come to us as Metamorph 3D print services. They want one part. In fact, we're fighting with some industries where they're saying we want 2-3 different parts for a tractor company, and they're just getting it done as a casting just with 3 parts. Now, if they asked me the same question 5 years back or 10 years back, I would have said no. We need hundreds of components for viability or even for doing it economically. But today, I can even print, or we can even print 1 to 2 to 3 parts customized from a model to a casting, and then he can use it and test it, because they are testing in a tractor, and those are all small volume equipment. So we now live in a digital world, and the digital world is going to look much more different. Completely the assembly lines are automated. Robotics are playing a big role in automation, and even manufacturing a car or a two-wheeler is completely controlled by robotics. You see very little people around there, and now that is also going to change a lot. And we live in a dynamic world. Now, in a dynamic world today, there are a lot of things which happen. Supply chain contractions, you have volatile labor conditions, you don't know tomorrow if the labor person will come or not. And then you have rapidly changing preferences. Now, in 3D printing or additive manufacturing, you don't have that problem. Because you set up a part in the evening today, tomorrow morning you come back, the iteration is ready, the part can be taken out. Now, again, you change that iteration of a new design, and then put it in the machine. By evening, you'll get another machine, you get another part. And then if you don't like that part, the next day morning you get another part. So within just 48 hours or even 72 hours, so to say, you get a completely redesigned or a newly developed product printed or rather manufactured and ready for testing on the field. Now this is what is going to be the digital, the factory of the future. And this is primarily what I'm setting as a context for this today's program. Thank you.
Hi. Let me go to Vimal now. Vimal, you have been in this robotic industry for a couple of years, and you have given a lot of solutions, especially into healthcare and things like that. So at the same time, the industry, 4.0 evolution has brought a lot of dynamics into the industry, and it has helped the people a lot in terms of empowering them and also the decision makers to make their process so fast. So would you please shed some light from your experience, please?
Okay, thank you, Roshan, for asking this question. In fact, when we talk about Industry 4.0, most of the people are extremely fear of losing their job, the change that we are incorporating. So our story is like we started from a campus, only in the dreams of robotics, and we thought we can use robotics for a lot of futuristic stuff like creating an Iron Man suit for the defense and all. But at one particular point of time, we identified that there are a lot of social problems in our society, like manual scavenging. In fact, in 2015, 2 people are died inside, and one more, 3 people are died inside in a manhole in Calicut. One auto rickshaw driver who tried to help the civil worker is also passed away. So we thought to use all this robotics and AI kind of technology for solving this kind of serious issues in our society. That's how we started. When we started in 2015, we does not have a lot of manufacturing capabilities in the location that we are. Almost all the places, even if they have machineries, getting proper things on time and all was a difficult situation. So we choose to take it on ourselves and we build our own factories and everything. In fact, in the journey, we created a world's first robotics company called Very Good Robot. And we deployed first time, that's in Kerala. And now, entire Kerala ecosystem, wherever the COH is here, under government department, we are handling that. And to the new stage, we deploy this robotics and AI. And in this deployment, we does not create any jobless. Rather, what we have done is like we empower the existing sanitation workers. So that's, I feel, one of the greatest empowerment which can be done to the lower strata of the society by using robotics and AI. This is one of the examples we have done. And in fact, how it is possible because, skill development is a very crucial situation. Creating a robotic device and it requires complex manpower to handle that. Then this, lower strata people cannot be, upskilled into this position. So that's where we again use technology for upskilling, making user experience much simpler. We work on building the user interface so simple that even a person, a illiterate person who does not have a lot of experience in education can also learn how to use robot in a very good way. So that is another example of how we, empower the people in the society using industrial 4.0 technologies, robotics and artificial intelligence, many things like that. Another example, we are also into health tech. Recently we went into health tech. Health tech, we are handling a particular situation called disability. Again, another social cost. Even though when we started, our dream was to increase the people's capability using exoskeletons like Iron Man suits and all. But then we find there are a lot of disabled people who look for normal life. And this can also achieve through Industry 4.0 technologies like robotics and AI. And that's what we have done. In fact, after 1 year of our launch of the product of this G-Gator, it's a gauge rehabilitation robotic device specifically for neuro rehabilitation. We install the product now almost everywhere in Kerala. Everywhere in Kerala, even in Calicut, Alicode Astor Hospital is having this, Kannur, Thane is also having. And in Trivandrum, even General Hospital is having this particular product called G-Gator. It's an advanced rehabilitation. And why is this required? It's like after a stroke or spinal cord injury, everybody occurred a temporary disability. And making them perfect after this disability, normally what is happening in most of the hospitals are, they are doing it manually. So when we do manually, they are not able to achieve the required level of rehabilitation which is required for the transformation. But using technology, we are able to do that. So now the people become disabled after stroke and spinal cord injury can be drastically reduced. This is one other way of example of how we can empower people using robots and AI. And we are now still working on many socially relevant projects using robots and AI. I hope in times we are able to help more people by using this technologies.
Perfect, Vimal. And Srikanth, moving forward, you started with additive manufacturing and into multiple stuff and a bit of definition and things like that. So how additive manufacturing contribution into this evolution and the digital transformation? If you can shed some more light into that, please.
Yeah, definitely. So can we swap the slide? Yeah, so I'll just keep my slides on here so that you can get the context of what I'm saying. So we talked about the manufacturing which is happening today, the traditional manufacturing, right? So you have physical inventory. Now, for example, Airbus was using different hangars to ship their, if they wanted a spare part in a particular aircraft hangar, the part has to be flown in from France or Germany or wherever to that particular location, let's say Singapore or let's say Dubai. So they have to, or Chennai, they have to transfer that part to that location. The part has to come in certain amount of time, then they have to fit it, then they have to start working on it. Now those days are gone. Now we have digital inventory. The digital inventory is available across Airbus platforms in cloud. So again, Industry 4.0. So the entire digital inventory of all the parts is available on cloud. So when an aircraft lands in one of the hubs, hangars, and if the part fails, immediately the code is asked for, downloaded, the code is downloaded, which means the part gets digitally downloaded from the inventory. Immediately at the hangar, there is a 3D printer which will print or manufacture the part. Aircraft is fitted with the part, aircraft flies. No logistics, no movement of the part, no movement of any other engineering part across the globe. It is just, in fact, logistics people are getting scared in the next 5 years, and CEOs of logistics companies are asking, what do we do when these logistics disruption? In fact, I saw a cover page in a magazine how the logistics are being affected by 3D printing. So that is the age where digital inventory is moving. So what is this? How does it help actually? Can I have the slide moved? Escape.
Yeah, it's there. You need to just escape that menu bar, please.
Escape. No, just press escape. Okay, leave it. So if you look at traditional manufacturing, quickly I will just say what are the limitations we have. So if you look at this part, there are 3 parts in it. So the front and the back and then the nut. Now all of these 3 can be integrated to one single part, built with a change of the structure and support material, and the hole changed from a round hole to a honeycomb kind of a hole. And because the 3D printing requires that kind of a whole structure and the lattice. So by doing that, you get just one printed part straight away. So 3 to 1. Now some cases we have 15 assembly parts to just single part. So that's a straight benefit of 3D printing. By overcoming traditional limitations in manufacturing, you don't have to make multiple parts, drill, machine, mill, and then finally assemble. All of that is eliminated. You directly print one part and finish it. I'll just cover a couple of areas there. So point of need of production. You don't need to keep stocks. You don't need to keep inventory. You just need to print when you need at that time to produce and immediately fit it. And I said about the aircraft example. So I'm going to share some examples. So earlier, we were talking about going to lathe, milling, drilling, and all of these things. Today, it is just press of the button. You just press print. And as Siemens was talking about, like Matthew, so you have digital twins, and then he's also talking about a lot of CAD software. The entire model is generated and ready to print. Now, you just press print, the machine takes over. So everything is then controlled by the printer to do the complete manufacturing. And these are things which are being changed in the digital environment. You can say that metal printers, composite printers are all changing it. And I'm not even seeing the slide. Yeah, the customers are leading the change. So customers have started using it. And a lot of companies, examples of here or there, I'm just sharing some example. So where industrial automation, aerospace industry, military and defense, automotive industry, healthcare and medical, research institutions, all of them have started using additive manufacturing, using composites and metal 3D printing. Two things are leading the world today. There's a technology called selective laser sintering, which is using nylon as a part, and then metal 3D printing using metal injection molding, so to say metal powder to being printed. These two technologies are becoming future technologies for us to print or manufacture both in composites and in metal. Now why composites? Because it's lightweighting, reducing cost, reducing time, drones, automotive parts, future mobility, EV vehicles, all of them are going to be in composites. And then metal with injection molding, small parts, does not need any die and mold making and tooling and all of those things. Straight away you take the model, go to the machine, print it, a powderized wire actually gets atomized, and then it prints to a small plate. And once it is printed, it is then actually engulfed with wax and another plastic, which is then put into a washing machine, which basically washes with a chemical, and then something called as furnace, where it is sintered, and then the wax is tapped away. So you get the final part. So when you print, you get something called a green part, and when you finally take it to the sinter and furnace, you get a fully ready part, machined, usable, straight away into the actual machinery, which is completely having the same strength of materials as a traditional manufacturing.
Fine, perfect. Vimal, tell me something. Srikanth has been showing, the automation into multiple industry like airline, aerospace, healthcare and all. So when it comes to the automation, people think about robotic, artificial intelligence and so on and so forth. So Even the survey report says that by 2030, the global GDP will be contributed by around 15 to 20% of, from artificial intelligence. So people are scared, in fact, the employees are scared. So what do you think? This AI and the robotics, are they going to replace the employment? I heard that, at one point in time, only certain job will be, reserved for human being, and the rest everything will be done by, AI and robotics. So it's so scary. And what do you think?
Roshan, actually, when I entered into Fireside, that time I asked this question initially, where this world is actually going with all this. And in fact, when the ChatGPT and all that, fusion, image creation, videos, even when I experienced those products, I find, I got scared. I got scared and I felt, if this is the way it's going, it's not far, then I'm going to lose my job, even. Because I find that, before there is a saying that artistic jobs and all is comparatively difficult to take by AI, which is more stable and numerical and data-driven kind of thing. But then when even artistic thing also changed into AI, it finds that any job can easily converted into AI. So, in fact, whatever we are seeing right now are the results of some of the research happened 7 years back, 10 years back, and now the world is moving in the back. There is a research is going on, general purpose robotic devices. In fact, this is the ultimatum where robotics and AI are going to do even physical jobs. Whatever we are doing right now, whatever linear, whatever industry, all that things can be automated by similar techniques which is already invented. It's only takes some more computation, some more programming, some more efficiency on solving. That's where another difficult. That's also we are solving one way or other. But ultimately we are getting into a place where human does not need to work anymore, and that's what happened even in the industrial era happened. Our hard physical labor is actually taken by machines. And right now people are not doing heavy duty applications, how we did the pyramids. That now we are using machineries for all that. Just like that, right now when you consider work, most of the things which is human using in that work is mental faculties. And AI is actually a substitute to do that. And it's getting very fast, almost all the complex mental faculties being replaced by AI. Then I thought, if AI started doing everything, what will happen to our economy, how humans will live in this society. So what I felt is just like how industrialization is did to our economy, the cost of goods drastically came down. And it's able to sustain that much population in our earth because of the industrialization. Otherwise, we are not able to sustain such population. So just like that, if AI is coming to the peak, economy will not be there because human does not come in any part of economic transition. So there is no need for human to interact with it. And in fact, this is helping human race in a way that we will get access to infinite resource. The limits are not just Earth anymore because of the AI and advanced technology. We can actually span across the galaxies and universe and get over whatever resources we require. And the technology we are solving right now is also help us to be able to sustain in other planets. So we should not be very stringent on one area of the job loss kind of thing, but the possibility that it can create is quite heavy, and I don't think anyone is actually stopped doing it. So now you can see the games, the sports and all this activity where we test our physical efforts, right? Because we don't need to do it in daily life. So just like that, the work-related thing will kind of a game or some kind of mental exercise that we do. So that's how the transition of economy is going to be. And I feel in the future that AI is creating the jobs where human interaction and genuineness and that internal consciousness because consciousness is the awareness, self-awareness, something is more than mind, the intellectual faculty and physical faculty. That type of particular jobs will stay. And in fact, when I look into the contents which is created by AI right now in most of the writing as well as the image, what it is doing is that it takes a lot of data set where humans is already created and it is getting into some kind of algorithm, and the output will be visually pleasing based on the ecological standard we have set in the society. So still, there is one particular area where human consciousness is also involved. So it's a little more difficult to explain it in a proper methodology. But the point was, for human beings, there is one more level that is the consciousness level, and whatever we find value in that level is going to be the only thing which is value in human being in the society that we are creating using AI. But I want to add one more point to that. In time, all these things will settle and we will have a very beautiful, heavenly kind of world. But the transition will be difficult, and that change is something where we need to prepare to handle the transition in a very planned and proper manner. Otherwise, that will create a lot of issues.
I want to say something here. So, Vimal should not scare the world. So, I will tell you practically what is going to happen. It is going to take 20 years. Don't worry. So, I am telling you that hardcore manufacturing will be there. But it is digital manufacturing. So, next 20 years, this is not going to happen completely that AI is going to rule the world. AI will change. Like for example, now about 10 days back, there is a software called Sora, or AI application called Sora, where you type in a text, you explain the text. The more you explain, the more the scene comes live. So if you say a turtle in a shell in a glass, and then it is moving in a ocean in a blue color and all that, within seconds you'll get a turtle moving in an ocean exactly like that, which is completely AI controlled. So Sora is the AI software which is doing this. So these are things which are now happening. But when you look at the digital inventory, digital part, and then the hardcore manufacturing, to answer Roshan's question, the market, the world will change. Actually, Kerala, Kozhikode can change with a lot, because you don't have to look at a huge space, looking at your terrain. You don't need huge space for manufacturing. So you can set up a small room. You can start going to an industry, ask for their problem statement, get their problem statement. Same day, you can sit on design, use a Siemens software application, get it installed, it's available on cloud, start working on a design software, and if the skill set is there with the CAD knowledge, you have CAD centers across everywhere, so do a bit of modeling, get the model out, get to a machine and 3D print them. Now if you can't print it, send it to us, we'll 3D print it and send it to you in 24 hours, because we have services. So you don't need to even buy a machine, but you can ask for a service. The service is available at the click of the button. And then once you are tested, once you are thriving on what is happening, then you can set up your own ecosystem at a fraction of the cost, saving time, reducing costs for the industry. So something which an industry cannot do, all of you startups, entrepreneurs, engineers, even college students can now do and serve the industry at large, which means we were never inventors of any products in India, right? All products are getting, iPhone was invented in US and here and there. So we have been on China and discovery. Now that is going to change, and Kozhikode can be a great destination, because you can start inventing products right here within a small area. We don't need big rooms, and that is what I would like to say in that context.
Perfect. So guys, you don't have to worry and don't get scared.
And you can see some of the industries was doing it. These are these examples, which was my next topic. So you can ask for that.
Yeah. So what I was trying to say is I've been into multiple, international exhibition in terms of AI. And so what they're saying is AI is going to open new scope of work. So only the thing is that, we need to be aware of AI and AI technology, and the job will be mostly AI-enabled job. The way, we used to learn Microsoft Word, Excel, and, years back, the job was only for those people. So similarly, going forward, the job will be reserved for, those who are aware of the AI technology and things like that. But multiple times of job, new JD, new scope is going to be created. So there are a lot of opportunities there, and you don't have to worry about it. And again, Srikanth to continue with, and also I think we need to reserve the last 10 minutes for some of the, questions from the audience. See, the 3D technology, for example, if I wanted to, buy a chair from a furniture shop, probably, moving forward, I can have a interior design and software like, AutoCAD or 3D, whatever it is in my computer, and I can connect to my 3D printer and print a chair the way, which I wanted in a couple of minutes or maybe in 30 minutes time. So is that going to happen? So where do you foresee this industry in next 10 years time?
Okay, you can have a small toy chair and put it on your table in 30 minutes, not the chair which you can sit on, because that's not going to happen so fast. But having said that, we have our printer which can print 1 meter by 1 meter by 1 meter, which means you can definitely do the chair and you can sit on it also. We have made those chairs also. It is working also. So it is, see, what is going to happen? In the last 5 years, something, I would say not 5 years, from 2014 to 2020, a lot of these desktop printers evolved, and people were playing, using it as toys to make small parts, play with that, plastics and Lego and a lot of small toys. You can make whatever you want. But from the so to say, merging between 2017, 2018 and onwards, people started making functional parts and end-use parts. So now we are moving to an industrial age, industrial additive manufacturing, where you can see here real-time R&D, manufacturing, aerospace, using the 3D printing to reduce time, reduce cost, be more lightweighting, composite, and actually a nozzle engine of an aircraft is being printed on 3D printers by GE. You can see here massive reduction in tooling costs, massive acceleration in previously impossible to do complex parts. Now if you see 3D printing, you need a complex design, and in the early stage we used to design for manufacturing capability. So whatever you are designing, the limitation is in manufacturing. Whatever capability you have to manufacture, only that much you can design. Now that complete barrier is flipped. Whatever you design, you can manufacture. Because any complex design, 3D printers can manufacture, because it's taking a code and sending it to the machine and printing it. Now, the only important thing is you have to figure out which technology you need to print, which material you're going to print, and which application you're going to print. So you have, for example, what we have is something from applications from plastics, thermoplastics, to polymers, wax, composites, carbon fiber, and finally metal 3D printing. So metal printing with stainless steel, copper, titanium, everything. So the world is of additive manufacturing is completely evolved. And if you see this slide here, a lot of big companies have started embracing 3D printing. GE is, invested $1 billion and set up their own metal printing companies, and they have acquired metal printing companies. Metal printing is growing phenomenally, and it is going to take over. So technologies are there. You're moving from a small area to an industrial application, and people are more serious today of printing functional parts. And today, from printing 4,000 to 5,000 parts a year, we can move to 10,000 parts a year. And in some cases, for example, hearing aid. Every hearing aid is different. Every individual hearing aid is different. Today, people are printing 1 million hearing aids in a month. So that is the capability through the resin-based printing. So technologies have evolved, and you need to know where you have to apply. And that's why I'm saying the future is very good, because you can start small, and within a very small investment of even 5 lakhs to 10 lakhs to even 20 lakhs, you can set up your 3D printing factory. No longer you need a large space, real estate space and all that. You can straight away go start printing. We have a printer called Figure 4, which is just about 20 lakhs, and it can print production parts. I'll show you a video in the next, if you want me to do it now, or shall I do it later? After the next question, I'll prepare for that. So if you just innovate and you can just print, you can print whatever you want.
Thank you for the example. Vimal, I'm coming back to you from a different perspective. But we talked about a lot of automation. And if we, talk about the multinational companies and the national brand, they have the technology department, CTOs, and so on and so forth. So they are doing the continuous R&D, and they come up with a lot of automation, and their business process engineering is completely automated and things like that. But again, when it comes to the small and medium enterprises, basically SMEs, they don't have much, dedicated department as such. But the entrepreneur or the brand owner or the decision maker, they really wanted to implement it, but they are scared and they don't know where to start with. So what is your message for the SME owners in terms of, this implementation? How do they start and where do they start? They may be, see, my question is basically, they are willing to do it and they don't have a technology expert in a house, hence they are scared. So what will be your message for the SME, owners to start with?
Okay, so in fact, somewhere or other, even we are using Industry 4.0 technologies like 3D printing also. I'll give you an example. Like last time when we are creating a drone kind of thing which goes into the water, with the manufacturing we only available one particular propeller in one direction. The other is not there. So creating a propeller is actually a very complicated process with all the surface and a lot of complications are there. Even if you go to traditional methodology, you do not get the perfection and the profiling and all this is very complicated. So what we did is like we did a scanning of the normal propeller which is available. We split the design and sent it to again Chennai, I think, probably to his organization only. And study our review for study it is right. It's almost like the exact same thing. So most of the decision making in our organization take place when we find the proper advantage in financial as well as the complexity of manufacturing and the result wise also. If the new technology, 3D printing and all is makes sense to us in that way, we'll move. And I feel to every SMEs which is there in the society and in Calicut as well as in Kerala, in our journey, in order to build the world's first robotics transit as well as the GK technology, some of this technology we are exporting to foreign also. We have to explore and load in that. So we allocate a specific budget at least for exploring a couple of things. In that exploration, we identified materials like carbon fiber and all as tremendous advantage than normal materials. And in a specific exploration, we identified it and we then figure out how well we can actually use it and what value we can give to client and what we can charge for that. So there are limitations of getting that kind of composite materials over here, but still I think last 5 years this is also improved a lot. Now in Palakkad and even in Trivandrum, you can actually create carbon fiber materials. Now this adds a lot of value to your products. And that exploration is the only reason where we could able to generate or create products in such qualities that even if we go for FDA also, they will okay with the particular technology we are doing. So, and that kind of exploration mindset should be there, specifically in this era where the technology is advancing so fast. Otherwise, it will be difficult to cope up with the development which is going there. And in fact, with the technologies like 3D printing and even carbon fiber and all, comparing to us, it's very new. But already in China as well as other countries, it's a very common product. So the technology that has gone over there. So that is the trust that you should have on exploring this kind of projects in our sense.
Yeah, just to add to that, when you talked about composite carbon fiber, we had a situation where customer in automotive wanted a fuel injection part and it had to be shipped to Korea and we had to do about 17 to 18 parts. Now it was impossible to do it in traditional manufacturing, no tooling, no die, nothing. We printed all of these 18 parts. He wanted specific requirement where a chemical has to flow inside. So we used carbon fiber. We used a steel high steel HSST glass fiber reinforcement. So these were printed in 4 different machines, 7 different locations, 7 days, and shipped in 18 parts were shipped within 7 days to the supplier, which is a tier 2 supplier, and they went and gave it to the OEM. It was taken to Korea, fitted into the vehicle, and being tested in less than 15 days. Now, this is a classic example. So that is where we are heading. And if you look at this picture here again, this is an impossible part if you want to do. Now here we are integrating robotics and metal 3D printing. So what you see in the left side is a robotic arm. So we use a robotic arm probably from his company or from Fanuc or from Yakashawa, many companies are there. You have BFW and other robotic companies. And we use the robotic arm, and the black one is a nozzle, which is a 3D printing nozzle from Meltio. So that engine completely takes a metal wire, and the wire is taken out, and you can see the pipe being bent and directly fitted into the arm, which means there's no limitation of size, limitation of dimensions. You can have a big pipe curled completely, made directly with the robotic arm movement. So there is multi-axis movement, multiple metal being spread directly and printed into the arm. So no bending, no operations on the left side. You have bending, turning, all of these operations are not there. Straight away, one command and the part is being printed directly out of metal. And we are not talking about powder metal here. We are talking about affordable stainless steel wire straight away being printed. So metal printing cost is also coming down. Almost like 50% costs are coming down. These are now used in something called MRO. That is maintenance and repair operations. And this hybrid additive is paving the world to make a lot of shipping operations, maintenance, repair operations, a lot of large-scale maintenance where, people today battleships. And I was talking to the MD of Mass Shipping Line. He says in shipping lines, in logistics, on the ship, they want to repair. And these are now going to be possible. Not just everywhere. For example, in carbon fiber, he said, we have a machine which can be uplifted from the air into the battlefield, dropped into the battlefield, and the machine opened, a composite machine opened, a fully printable power with the batteries, and you can print, and a maintenance kit also given. So if anything goes wrong with the machine, you can even repair the machine. Everything on the battlefield for defense applications. So that's the area where we are.
So, interesting. All right. I think we are getting into the timeline. We have around 5 to 7 minutes to take some question from audience. Let's move on, please. And you feel free to please ask the questions.
So meanwhile, I'll just flash some slides where you can see some parts. So just for example, you can see some parts are being produced and what time it is taking and how much time it's printing the part and what kind of parts you're actually producing. This is the DLP, the SLA machine called stereolithography. So we can see the kind of production parts we can make. It's a single machine making all these parts, and you can see the dimension and the time it's taking to print those parts. Any questions?
Any 3D art for medical application or human?
Can you repeat the question, please? Can you repeat the question, please?
Yeah, in 3D printing, now medical science is progressing fast. A lot of things are being artificial lungs, artificial heart, a lot of things are being made. So any 3D printing has come into the medical area?
Medical in India? Quite a lot. So as I said just now, the hearing aid. So that is for the application for hearing aid. Now another area which is being predominantly used and a huge savings is what we call as the surgery planning. So if you look at hospitals, operating theatres are very expensive. So your cost of the operation is dependent on the amount of time you spend at the operation theatre. Now with surgical planning, you can, for a kidney stone or for any other specific issue like a knee surgery or something, the doctor can CT scan you, which is normally done. And then that CT scan is given to the 3D printer, like a powder or whatever form it is. The entire part is given to the doctor. So the doctor assesses the part, knows exactly where the kidney stone is, and when he goes to the operation theatre, his operation time is reduced by 50%. And that is very much happening. So that is in the pre-surgery planning. Now when it comes to dental, there are now very precise dental 3D printers which can do crowns, dentures, fixtures, guides, everything. In fact, there are dental labs which print your complete ceramic tooth also. Okay, that is advanced very much. Jewelry, full advancement. Hundreds of printers in Mumbai, in Seab area, which is converting from wax to jewelry directly. So from wax, it goes to casting. Almost all your new jewelry from Joy Alucas to Carrot Lane is all being 3D printed. We don't know. But today, if you order in Carrot Lane, which is for popular, we have done it, the Carrot Lane gives you a plastic part, which goes to the customer puts the ring or the jewelry, checks it, and if it's fine, that same plastic part is given back to the client, to the Carrot Lane gives it to the factory, and it is poured directly into metal. Jewelry is made exactly as per the plastic or the rubber part which has been shown to the customer, no changes. So that is in jewelry, that is in dental. In terms of implants, we have titanium implants, knee implants, bone, lot of things like rods are all slowly being changed. Very classic example, if you see in medical, I had a call 5 years back from a strange company or actually a organization which said, can we have a turtle coming out of the sea? Can you help us? I said, what has turtle got to do with me? Now actually what happened was the turtle had a shell, and the shell had a jelly kind of a format, and somewhere they saw in the US that jelly was 3D printed. So we can change that profile of the shell, because the turtle can survive only with the shell. So if you can 3D print that shell in the jelly format and put it on the the turtle can survive and go back to the sea. Now that was 5 years back. Unfortunately, we did not have that jelly or whatever the material at that point of time, but it is possible. So medical, yes, it's a lot of advancements are there, from surgery planning to implants. By the way, tissue engineering, I spoke about it 6 years back. Organs like heart, kidney are all being made in tissues. You don't no longer need donors. Doctor doesn't have to wait for donor. You can just order a kidney. Your kidney will be printed, it will be fitted, and the patient can finish the surgery. The doctor does not have to wait like before for a donor. The donors are not needed. You just need the tissue exactly, and human tissue can be used to make that print that kidney, and organs can be printed now, and hearts are being also printed. Actually, live it is being printed. You can look at an institute in the US. I think it's called Wofus or something. I'm not sure exactly, but it is happening, and there are bioprinters which are now printing these organs, and it is becoming mainstream slowly. You can see that happening shortly. In fact, even your skin crafting is happening. If you lose your skin through fire, you can now have your 3D printer, which is like an inkjet, printing your skin, and then whatever skin you have lost can be crafted, and you will have your skin back exactly as per original, and the skin will look exactly like what your skin is. So that level of tissue printing is happening.
Srikanth, I think one more question from you, sir, right?
Sorry?
Hello.
Yeah. Go ahead.
Speak, yeah.
Hello.
Yeah.
Sir, I have a question regarding your device. I mean, the work that you're doing. So, is there any limitations that you have felt during your experience over the years with 3D printing?
Limitation.
Yeah, limitations. As in like.
Yeah. Good question. Yeah, of course, any technology, any new advancements will have limitation. Okay, rightly asked. In fact, there was a slide on that. So the limitation is in the volume. So we cannot still do mass production. We cannot do, see for example, I went to a factory, he can do millions of parts or hundreds. He's doing, for a Bosch, my friend is printing lakhs of spark plugs in a day. So we cannot do that. In 3D printing, we are talking about something like hundreds to thousands, to it has reached now 10,000s. As I said, customized millions of hearing aids. But if you look at the same part being produced hundreds of times or thousands of times or lakhs of times, then there is a limitation. The limitation is not about printing. The limitation is about the cost. So you can, as you go in volume, cost has to reduce. So cost cannot reduce so much right now. So and speed. 3D printing is not still up to speed where you, for example, you talked about carbon fiber. So the part which I told you, which took 7 days to print across 4 different locations, took 32 hours to print. It was a small fuel injection part, but it took 32 hours to print. So speed is a limitation, volume is a limitation, materials are crazily expanding. We have some exotic materials now, but still there are some limitations in material. For example, aluminum printing people are asking, but aluminum is only available in a costly metal, powder metallurgy, not in wire form. We are still exploring aluminum in wire form, because once we can bring aluminum in wire form, we have a very low cost of 3D metal printing, and aluminum is 70% metal used for a lot of applications. So there are limitations in volume, speed, and the materials, and the cost of the technology. So the machines I'm showing here, that robotic machine is about 1.5 crores. So those are still limitations. You can buy machines for 20 lakhs, you can buy machine for 10 lakhs, but the things like 2 lakhs and 3 lakhs machines, you can play, you can make some plastic parts, but you cannot do actual industrial parts. So serious industrial 3D printing is anywhere between 10 to 20 lakhs, upwards to 2-3 crores. So that is again another limitation. So all of these barriers are there slightly. Otherwise, it's a great place.
Thank you. So I do have a follow-up question. So do you think these costs can be lowered in the future, whereas these parts are available with much cheaper and affordable? And also, do you think these the products that we manufacture, these devices are recyclable and they can be used again with the same product or the same devices?
Excellent question. In fact, recently 3D Systems, a large well-known company in 3D printing, and one of the pioneers who invented 3D printing, they brought in or acquired a machine called Titan Robotics. Now this machine can use in plastics. You don't need any filament, you don't need fiber, you don't need anything. You can just use pellets. And now, in fact, one of the companies used sawdust and even waste material to print. So they have a hopper. In the hopper, you just throw the pellets or the particles. It will convert it into filament and 3D print it into a plastic form. So it reduces the cost, time and speed. And one more thing they've done in the Titan is they've added a machining part, like a CNC machining. They've added the machining tool. So you print the part, you machine the part, take it out, fraction of the cost, fraction of the time. So it's a large machine. The machine is about 2-3 crores, but then it has reduced time, cost, and a complete open source of materials. You can have PLA, you can have ABS, you can have exotic materials, waste, sawdust, even wood. Many materials are available today. That's available in Bangalore right now. You can test it. Thank you.
With that, I think we conclude this session, and the session is getting ready, and they're waiting for which. And what I expect is basically, from 3D printing and the robotic and automation perspective, the great speakers, Mr. Vimal and Mr. Srikanth, they have wonderfully delivered, and they have shed some light in terms of very high level. And yes, the session we intended, in fact, at a macro level, because it's a 40-minute session only. But what we tried is, apart from the macro side, we get into some micro level and to give some more light. So again, don't worry about the AI, and it's not going to lose any job. It's going to create more jobs only, but we have to be AI enabled and we have to be AI knowledge. Once again, thank you very much.